Okay, so I got cut off. I really do talk way too much, I think. You'll probably agree. Um, so I don't remember where I was, but to find the area of the base, to find big B, you need to find the area of the triangle. The triangles are the bases. Even though they're not sitting on the triangles are the bases because they're parallel to each other and they're attached by the height. So let's go ahead and write down what big H is. I'm going to start putting a big H here because that's the height of my prism. The height of my prism is 10. Okay, so in order to find big B and perimeter, I need this missing piece right here. Well, it's easy if you remember your triples. If you don't, then do Pythagorean theorem. 13 squared minus 5 squared equals B squared. So that ends up equaling 12. And now, now that I have the base of my triangle little b and the height of my triangle little h, I can find the area of that triangle, base times height divided by 2, which is 30. And the perimeter of the triangle is conveniently and coincidentally 30. Okay, so it's time to do the formula. 2 big B plus B times H. 2 times 30 plus 10 times 30. This 30 being P, this 30 being big B. Pretty simple to do. That's 360 for total. That is millimeters squared. And the lateral surface area is just this part, which is simply 10 times 30, which is 300 millimeters squared. Okay, cylinder, easy one. Equation, 2 pi r squared plus 2 pi r h. Two variables only. R is 5.5, h is 5, and I'm going to pick up my calculator and calculate this out. So 2 times r squared plus 2 times r times h. It's really all you have to do when you leave it in terms of pi is 2 times 5.5 squared plus 2 times 5.5 times h. That's a lot of fives. All right, so grabbing my calculator, doing it all in one step, 2 times 5.5 squared plus 2 times 5.5 times 5. All right, so that gets me total surface area of 115.5 pi feet squared. And the lateral surface area is 2 times 5.5, which is 11. 11 times 5 is 55 pi. Oh gosh. Okay, so we've got a. Sorry about the oh gosh. That just, I have the same reactions as you. So it's a prism. First and foremost, it's a prism. So 2 big B plus B times H. Big B, P, and H. The height of my prism, I like to kind of start at the capital H. This 10 is the height of my prism because it's connecting my two parallel trapezoids. Okay, that's why this is called a trapezoidal prism. Okay, so I'm going to erase all my little markings. I've already isolated what capital H is. So capital H, or the height of my prism, is 10. All right, now for big B. Big B is the area of a trapezoid. Area of a trapezoid is, so big B can be found by doing little base 1 plus little base 2 times little h divided by 2. That's the area of a trapezoid. I'm going to do this in my head. This is B1. This is B2. You have to look sometimes front to back to find your two heights because the pictures give you the numbers sometimes in different locations. So B1 plus B2 is 20. 20 times the trapezoid's height. Don't mix the trapezoid height with the prism height. Trapezoid height is 6. So 8 plus 12 is 20 times 6 is 120. Divided by 2 is 60. So big B is 60. And the perimeter of my trapezoid is 7 plus 8 plus 9. I can see it's 9 from back here, plus 12. So 7 plus 8 is 15. 15 plus 9 is 24. 24 plus 12 is 36. Now I have what I need to put in my calculator. 2 times 60 plus 10 times 36. 2 times 60, 120 plus 10 times 36 is 360. I have again my two answers in one. I have my total, which is 480, and my lateral, which is 360. Okay, and that's units squared. There's two dimensions here, length and width. I know it's a three-dimensional object, but we're dealing with the surface area, and area, whether it's of a three-dimensional object or a two-dimensional object, area is units squared. Area is two-dimensional. Now, I'm stressing that because this is what we were going to do after spring break. This was the end of the previous unit that I didn't get to. So there's this idea if you change the size of a shape. Let's look at number 11 because I think it's a little easier. All right, surface area. That's why I was just stressing on the previous question that it's two-dimensional. That means there are two dimensions. And so if the dimensions are multiplied by 3 and there are two dimensions, you're multiplying 3 times 3. So if the dimensions are multiplied by 3, then the surface area, the effect on the surface area is 9 times bigger. If your two dimensions are cut in half, then length is cut in half and width is cut in half, which means the total surface area is 1/4 the size. Okay? If you were to multiply the dimensions, times 1/3 or shrink it by 1/3, your surface area would be affected 1/3 times 1/3 because you're taking 1/3 the length and 1/3 of the width, and so the grand total change would be 1/9. I'm not looking for a number. The question doesn't ask you to give the new surface area. The question's just asking what is the change in the size. Well, if I were to multiply the dimensions by 1/3, the surface area would be 1/9 the size of the original calculation. Number 11, this would be 9 times. If I were to calculate the surface area from 4, 5, and 9. Let's do that real quick. All right. Now, I think this is one of the previous questions. So the surface area, if you notice number 11, the surface area, I think this is question number 1. Let me turn the page, back a page. Yeah, that's the picture from question number 1. So look at the total surface area, 202. It had a total, oh, my eraser's on. There we go. So this had a total surface area, 5, 9, and 4. Question 1, 5, 9, and 4. That had a total surface area of 202. Now this has a total surface area of 202. Now, I predict that if I multiply these dimensions times 3, if I make these dimensions 15, 27, and 12, I'm definitely going to need a calculator. I promise you, if you plug these 3 numbers into the surface area of a prism equation, you will get a surface area that is 1,818. Okay? 2 big B. I'm going to see if I can pull up my calculator. Let's see. So 2 times my big B is 27 times 12. That's 2 big B plus the perimeter. 27 plus 12 is 39, 78. The perimeter is 78 times the height of 15. And it's 1818. So if I change the dimensions by 3, then the surface area is changed by 9 times. Okay, that ends surface area of prisms and cylinders. And I will make another video for pyramids and cones.